All right, 1.5 quadratic equations, day 2. So today we're going to solve quadratic equations by completing the square by using the quadratic formula. We're going to talk about when to use which method, and we're going to solve a problem that's modeled by quadratic equations. So what we've done up to now is we have solved quadratic equations by factoring, right? But we know that not all equations are factorable. So we have to have another way to solve those that are not factorable. And one of those methods is called completing the square. So it says here, if x squared plus bx is a binomial, then by adding b over 2 squared, which is a square of half the coefficient of x, a perfect square trinomial will result. That is that x squared plus bx plus b over 2 squared is equivalent to x plus the b over 2 squared. All right, so let's talk about how to just solve a piece by doing, so let's just talk about how to do completing the square. We're not going to solve the equation here, okay? All right, so let's just say I have this x squared plus 16x. And in order to make this a perfect square trinomial, I'm going to need to add some number so that when I factor this, it's going to give me the same exact thing in both of the parentheses. All right, and so they tell us to use this formula that b over 2 squared. So in order to complete the square, we're going to use b over 2 squared. B is the term in front of the x. It's the coefficient of x. It's a number in front of the x, which includes that sign. So in this case, our b is a positive 16. We're going to divide it by 2, and then we're going to square it. So 16 over 2 is 8. Squared is 64. And so we're going to put a 64 in that blank. All right, so now we have x squared plus 16x plus 64. And we can factor that. And if this is a perfect square trinomial, I'm going to get the same thing in both these parentheses. So let's try it. So we know our first terms have to multiply to x squared. And we know our last terms have to multiply to 64, but they also have to add to the 16. So that's going to be 8 and 8. Bring down your first sign because we put the bigger number, but since it's the same, it doesn't matter. And then this is a positive 8 times what kind of 8 would give me that positive 64? It's positive. Now note that both of these, they're exactly, well, both parentheses are the same, which, yay, that's what we wanted. And also that positive 8 is the number, it's that b over 2. It's the number we got right before we squared it. Every time, guys. It's going to work every time. All right. And then back over here where it says x plus 8 times x plus 8, because they're exactly the same, we can write that as x plus 8 squared. And if we had this inside of an equation, we would be able to solve using our square root property. All right, so now let's apply that to actually solving an equation. So example 1a here says complete the square for this problem. And so I'm going to write down the steps as we're doing this, because now this problem looks a little different than what we had before, right? We just had an x squared and an x term. Here we got a minus 1, we got an equal sign, okay? So our first step to completing the square is we want to isolate the x squared and x terms. So I need to get x squared and x terms by itself. So I'm going to rewrite this over here so I can do it and not in the middle of my paper. All right, so since I need to get these two by itself, I'm going to move this 1 over by adding it because it was a minus. So now we have x squared plus 4x equals 1. Okay, our second step is we are going to common factor or divide out the number in front of x squared. So here we just have a 1 in front of the x squared, but if we had a different number, it would make a big difference, okay? So we're going to common factor that out. So remember, you always write it down, open a parenthesis, and then actually divide it out. So when I divide both of these by that 1, I still get x squared plus 4x, and then just bring down your equals 1. All right, so our next step is we're going to add a blank inside the parentheses hold on, add a blank inside parentheses, and on the other side of the equal sign. Okay, now when we add in that parentheses, it's going to go after the x term, okay? So we're going to bring down our 1, parenthesis, x squared plus 4x plus a blank, close your parentheses, equals 1 plus a blank. Because remember, for an equation, which you add to one side, you have to add to the other to keep it equal. All right, so step 4. We're going to complete the square. And fill in the blanks. So remember to complete the square. This is where we do that b over 2 squared. Well, b for this problem is going to be that positive 4 over 2 squared. 4 over 2 is 2 squared, which is 4. So that's what we're going to put in this first blank. But remember, we've got this number now that we factored out, that's on the outside of that parenthesis. So if I was going to work out on the left side here, I would have to distribute the 1, wouldn't I? So remember, this 1 is going to be multiplied times that 4. So whatever number you got here, you're going to multiply it times what you put in your first blank to get what you're going to put in the second blank. Well, 1 times 4 just happens to be 4. All right, so step 5 is we're going to factor the left side and combine like terms on the right side. So I'm going to write this down this one time. I'm just going to bring down what I have in step 3 written down here now, so that I can factor right underneath it. All right, so we're just going to bring down our 1. This is a simple trinomial, so we're going to open 2 sets of parentheses. Now, in order to factor, remember our first terms have to multiply to x squared, so x and x. Our second terms here are going to multiply to the 4, and then read it backwards. They're going to add to 4, which are 2 and 2. Bigger number first, doesn't matter since they're same, so bring down that first sign, so bring down your plus. And then a positive 2 times what kind of 2 would give me that positive 4 at the end? Positive 2. But remember now, we said that number that's in the parentheses with the x is always the number we got right before we squared it, which was a positive 2, so we did it right. All right, equals, and on the other side, we got 1 plus 4, which is 5. And then our last step is we're going to rewrite and solve. All right, so we're going to come up here. So when I rewrite this, I get 1 times x plus 2 times x plus 2 is x plus 2 squared equals 5. Now I really don't have to have the 1 in front because it's just 1 times. So I'm going to drop it. If it was any other number, we would need to divide by it, okay? And then solve. So to get rid of the square, we're going to take the square root. So it gives us x plus 2 equals, remember you get plus or minus. We can't do anything with 5. 5 is prime, so leave us the square root of 5. Solving for x, so subtract the 2. And so we get x equals with a negative 2 plus or minus the square root of 5. Sorry, I know it's a little crowded there, but that will be our solution. We can't combine them because they're not like terms. And remember, if it has a square root or an I, when you took the square root of it, if it doesn't simplify down to a whole number or a fraction, something like that, then you need to just leave it in radical form. All right, so 1b. So this one I added into the notes, so you may not have it in your notes. Be careful because example 2 looks just like it, but it's got different directions, okay? So we're working the same problem. We're going to do an example 2. We're just going to do it by completing the square. We're in example 2. We're going to use a different method. All right, so this one should go a little quicker because we don't have to write the notes all down. So we have 2x squared plus 2x minus 1 equals 0. And so remember, our first step is to isolate the x squared and the x term. So we're going to move this 1 over. And so we have 2x squared plus 2x equals 1. Then our next step is we're going to common factor out the number in front of the x squared. So I'm going to take out this 2. So I'm going to divide both of these by the 2. And that leaves me with x squared plus x. And then bring down your equals 1. Our third step is said to add the blanks inside the parenthesis and on the other side of the equal sign. So we got 2 times x squared plus x plus a blank. Close your parentheses, equals 1 plus a blank. Step 4 is to complete the square, which means we use a formula b over 2 squared. Complete the square and fill in the blanks. So for this problem, or for any problem, remember b is the number in front of the x, which for this problem is a positive 1 over 2, and we're going to square it. Now I know y'all don't like fractions, but remember to be squared just means times itself. And you multiply fractions straight across. So 1 times 1 is 1, over 2 times 2 is 4. So 1/4 is what we're going to put in that first blank. But now remember, really this 2 gets distributed to everything inside the parenthesis, doesn't it? So I'm going to take that 2 times that 1/4 to get what's going to go in that next blank. So I'm going to do that up here in a thought bubble. So I have 2 times 1/4. Remember, 2 is a fraction, is 2 over 1. We just said we multiply fractions straight across, so we'll get 2 over 4, which both of those numbers are divisible by 2, so it reduces to 1 over 2. So we're actually going to put 1/2 in our blank. All right, so then, let's see, we filled in our blank. So then sorry, I had a distraction here in the classroom. All right, so then step 5 is going to be to factor and combine like terms. So I'm going to bring down that 2. I'm going to factor this trinomial, so I know I need 2 parentheses. My first terms are going to multiply to give me x squared, so x and x. My last 2 terms are going to multiply to 1/4 and need to add to 1. Ooh, we haven't done them with fractions before, right? What are we going to do? I'm going to remember the fact that the number that goes inside with x when we do completing the square is always the number we got before we squared it when we did completing the square, which is a positive 1/2. And you can check it. If you multiply 1/2 times 1/2, you get 1/4, which we did. And if you take 1/2 plus 1/2, we also get the whole number 1. So that's correct. Equals, and on this side, we got 1 plus 1/2, which I'm just going to put as 1.5. And then finally, step 6 says to rewrite and solve. So we're going to 2 times x plus 1/2 times itself is just x plus 1/2 squared, and then equals the 1.5. So I'm going to rewrite that up here again. And now let's start solving. So let's divide by the 2 so we can get the squared part by itself. So x plus 1/2 squared equals 0.75. Now to get rid of the square, we're going to take the square root. So x plus 1/2 equals plus or minus the square root of 0.75. Now normally we don't put decimals underneath a radical. And so that's because this problem really wasn't set up to do completing the square with. I mean, it's definitely possible to solve it, but it's not one that we would normally pick for students to do because it has that decimal in it. So tell you what, so that we can compare this later, well, no, just leave it like that. All right, so we get x plus 1/2. Well, I'm sorry. So we're trying to solve still for x, so we need to move over the 1/2. And so we get x equals negative 1 over 2 plus or minus the square root of 0.75. And so that would be our solution, even though we don't like decimals in fractions. I meant decimals in radicals. Now, I'm going to show you something so that when we do this problem with the quadratic formula in just a minute, you'll be able to compare the answer and see that it's the same. All right, so remember the 0.75 is the same as 3/4, right? And if you're taking the square root of a fraction, that's the same thing as taking the square root of the top over the square root of the bottom, isn't it? And so we end up with, on this one, we get the square root of 3 over the square root of 4 is 2. So we could write this answer as x equals negative 1/2 plus or minus the square root of 3 over 2. And this is the answer that we're going to see in just a little bit. All right, so we did completing the square. Oops, sorry, my thing froze there for a second. All right, so we did completing the square. Maybe not our favorite because it's totally new to some of us, but it is a way to solve it, okay? And another way, though, to solve is your quadratic formula. So it says the solutions of a quadratic equation in general form, ax squared plus bx plus c equals 0, where a can't equal 0, are given by this quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now notice it says it has to be an ax squared plus bx plus c equals 0. So you have to make sure your equation's equal to 0. If not, you have to make it equal to 0. And that the a value, the number in front of the x squared, can't be 0, which means b could be 0, so I may not have an x term. So if x isn't there, if it's just 2x squared plus 4, then that means my b is going to be 0. If I don't have a constant term there that doesn't have an x, then that means my c value would just be 0. All right, so let's look at example 2a here. It's the same one we just did, but now we're going to solve it using our quadratic formula. So the first thing we need to do is make sure that our equation is equal to 0, and it is. So then let's identify our a, b, and c. A, remember, is the number always in front of the x squared. B is the number that's always in front of the x, and c is always the constant number. It's the one with no x. So then we're going to plug into our formula. So x equals negative b plus or minus the square root b squared minus 4 times my a times my c all over 2 times my a. And so now we're just going to simplify this. So I'm going to start, I'm going to work out this piece. So I got a negative 2 plus or minus. Guys, don't put the square root in your calculator, okay? You can put what's underneath it in your calculator to get that answer, but don't put that square root. If it's not a perfect square underneath it, it's going to give you a decimal, and there's no way for you to change it back without actually going back and reworking it. So you might as well just work it the first time. All right, so then underneath it, we have a 2 squared, which is 4. And then we have negative 4 times 2, which is negative 8, times negative 1, which is positive 8. All over, we get 2 times 2 on bottom, which is 4. So now I'm going to work what's inside my radical. So x equals negative 2 plus or minus the square root of 4 plus 8 is 12, all over 4. So we got x equals negative 2 plus or minus, that square root of 12. It's not a perfect square, but I can break down that 12, so I need to do that. I'm going to come up here, break down my 12. So I'm going to say 3 and 4. 3 is prime, and 4 is 2 and 2. So we're going to take out a 2, and we're going to leave the 3 underneath. So instead of writing the square root of 12 now in my problem, I'm going to put the 2 square root of 3, and it's all over 4. And then remember, always check to see if you can reduce the numbers that are outside of the radical. So I have a negative 2, positive 2, and a positive 4. Well, they're all divisible by 2, so I'm going to divide them all by 2. And so I get negative 1 plus or minus 1 square root of 3 all over 2. But remember, this 1 that's in front of the radical is just 1 times the square root of 3. So I could rewrite this as negative 1, x equals negative 1 plus or minus the square root of 3 all over 2. And that will be our solution. Now don't forget though, they could write it separate, right? They could split this up. Sometimes we've seen that in our work. So we get negative 1 over 2 plus or minus the square root of 3 over 2. But wait, that's the answer I told you to look for when we did this in example 1b, isn't it? So you can see that we worked it 2 different ways, but we got the same answer. Because it's the same problem, you'll get the same answer. All right, and 2b, yes, this is the same problem that we did in 1a, but now we're going to solve it using our quadratic formula. So first thing we need to do is identify, well, first thing is to make sure that it's equal to 0, and it is. So then we identify our a, b, and c. So a is 1, it's the number in front of x squared, b is the number in front of x, and c is the number with no x. So let's plug it in our formula. So x equals negative b plus or minus the square root b squared minus 4 times a times c all over 2 times a. So now I'm going to go through and simplify the pieces. I got a negative 4 plus or minus, keep the square root, work underneath it. 4 squared is 16. Negative 4 times 1 is negative 4 times negative 1 is positive 4 all over, and 2 times 1 is 2. Now I'm working under my radicals, so I get x equals negative 4 plus or minus the square root of 16 plus 4 is 20 all over 2. So we get x equals negative 4 plus or minus, we can't take the square root of 20, but we can break it down. 20 is what? 4 times 5, which is 2, 2, and 5. So I got a pair of 2s, so take one out, and the 5 stays under the radical. So 2 square root of 5 all over 2. Remember to check to see if the 3 numbers outside of the radical are all divisible by something. And these are all divisible by 2 as well. And so when I do that, I get x equals negative 2 plus or minus, we get that 1 square root of 5, so I'm just going to write square root of 5 all over 1. But do we have to put divided by 1? We don't. So we get x equals negative 2 plus or minus the square root of 5, which is actually the same exact answer we got in example 1a when we worked out the same exact problem using a different method. All right, so how do we know which method we want to use? Well, one thing, if the directions tells us that we need to do it a certain way, that's the way we should work it. All right? Otherwise, quadratic formula, guys, works for all quadratics. If it has an x squared as your largest term, then quadratic formula is going to work. All right? Completing the square will work for all of them as well. Completing the square, though, gets a little trickier sometimes when that b is an odd number, because that means when you divide it by the 2, you're going to end up with fractions, okay? But completing the square will work on all quadratics as well. And then factoring, well, factoring works if factoring works, okay? You just have to check it out. If it's a simple trinomial, I would check it factoring. If it's like an alien, I probably might use the quadratic formula. All right, and then we did that square root property, which is what we do when we're doing the completing the square, when we take the square root of both sides. So I would use it if I had just a squared term. If I didn't have a b term, if I didn't have that bx, then I would use the square root property to help me. All right, so let's look at an application here. So it says the formula P equals 0.01 a squared plus 0.05a plus 107 models a woman's normal systolic blood pressure P at age A. Use this formula to find the age to the nearest year of a woman whose normal systolic blood pressure is 115. All right, remember, guys, I've told y'all, if they give us an equation, let's look at it and let's identify those variables. I have two variables here. I have a P. What is P? Well, it says the systolic blood pressure, P. So P is my blood pressure. Makes sense, P for pressure. And what is the age? It says at age A. So A is our age. Now then it tells me here that we've got a blood pressure is 115. So that's my P value. Now if you read up a little bit more, it says find the age. So we're solving for A. So I'm going to plug in my 115 for P. Now, this has a squared and a instead of x and x squared. Does it matter? No. If you want to change it to an x, you can, or you can leave it as an a. Now, we have to choose which way do we want to work this. Well, I see decimals, so I'm thinking, I don't really want to even try to see if it's factorable. We have an a squared and an a term, so the square root property is totally out. So, it looks like I'm down to, do I want to do completing the square, or do I want to do the quadratic formula? Since my a term is an odd number, 0.05, I really don't want to do completing the square, so I'm going to choose to do the quadratic formula. All right, but in order to do the quadratic formula, remember your equation has to be equal to 0. So I'm going to subtract that 115. So I get 0 equals 0.01 a squared plus 0.05 a minus 8. And if I'm going to do the quadratic formula, I need to identify then my a, b, and c. So a is going to be the 0.01, b is going to be the 0.05, and c is our constant with no x, or no a in this case, which is -8. All right, so we get x equals -b plus or minus the square root b squared minus 4 times a times c all over 2a. So we get x equals -0.05 plus or minus the square root of. Now, some of your calculators will let you put all of this in. If you have one of the graphing ones or one of those that has it where you can write it across the screen, you can put it all in at once. So let's do that in this one, because we've done it the other way on the others. And so when I do that, I get 0.3225. And then it's all over 0.02. Well, normally we would say I can't take the square root of 0.3225 and get an actual whole number. So normally we would just say, okay, we're done. But guys, we need to answer the question. It said, what is a woman's age? I have no clue what our answer is right now in years. So we're going to go ahead and work this out. The thing is, we have that plus or minus. So this is where we're going to split it. We're going to solve when x is equal to -0.05 minus the square root of 0.3225 all over 0.02. And we're also going to solve when x is equal to -0.05 plus that square root of 0.3225 all over 0.02. All right, so we're going to put this in our calculators. If you're trying to put it all in at once, you're going to need to put that numerator in parentheses on both of them because you have more than one thing there. All right, so if you need to, pause the video so you can do that. So when I do this one, I get x equals -28.44. And when I do the second one, I get x equals +28.34. Now, remember, x is our a, right? And a is our age, or the age of the woman. So, first thing is, do both of my answers make sense? No, we can't have a negative age. So that answer's out. The other one does work. Now let's see. It says use the formula to find the age to the nearest year. So we need to round this. 28.34 rounds to what? 28. So we could just say that she is 28 years old. Now, that -28.44, let's talk about it real quick here, guys. Okay, that answer is a good answer for the equation we looked at, okay? So when 115 is equal to all the rest of that, that is an answer. But for our problem, for the scenario that we're looking at, it doesn't work because we can't have ages negative, and that's the reason we threw it out.